The moon is often overlooked, yet its presence in our sky is truly captivating. Its size and proximity allow us to discern surface details effortlessly, such as the dark mare and bright craters. While observing the moon through a telescope is already awe-inspiring, the content of this video surpasses the telescope's perspective. We are fortunate not only to have visited the moon, but also to currently possess an orbiter equipped with a powerful camera. This camera has been scanning the lunar surface since 2009, providing us with a unique vantage point. What has this orbiter observed? Join me in this video and I will present some of the most recent intriguing and perplexing images captured by the Lunar Reconnaissance Orbiter, LRO. Let's kick off with an inconspicuous, unnamed crater. Inside it, you'll notice numerous tiny craters. Surprisingly, this crater is nested within another one. Follow me on this journey. As we zoom out, it becomes apparent that not only are these craters within another crater, but they are seemingly enclosed within two impeccably aligned craters. However, is that truly the case? Well, uncertainty lingers. Both of these craters bear the name Belle E crater. This distinctive crater type is referred to as a donut or concentric crater. While it's conceivable that they formed from two impactors aligning neatly, further investigation raises doubts. If these craters were the outcome of random collisions, there should be a haphazard distribution of concentric craters across the moon's surface. Yet, that is not what we observe. Take a look at this intriguing phenomenon. Concentric craters tend to cluster in specific regions, notably around the periphery of Oceanus Procellarum on the moon. Adding to the intrigue, most of these craters share similar ages. Delving into the details of an individual crater provides further fascination. The outer crater should theoretically be approximately twice as deep when compared to other craters of similar size across the moon. While some concentric craters may result from double impacts, the concentration of these features, along with their consistent age and unusual depths, suggests a more complex story. One hypothesis proposes that certain impacts occurred during a time when the moon's surface in this area exhibited a state between solid and liquid, akin to cool lava or honey. The impact created ripples that propagated outward, halting before smoothing off and eventually freezing in place. However, this is considered a less likely scenario. A more plausible theory suggests that during a more geologically active phase of the moon, craters in the region were elevated from beneath by magma attempting to reach the surface. This explanation accounts for the shallowness of the crater and the observed concentration of concentric craters in specific lunar areas. Despite the leading theory, uncertainty persists, and the definitive explanation remains elusive. What are your thoughts on this intriguing lunar mystery? Now, aside from sporadic meteor impacts, you might believe that the moon's surface remains relatively unchanged. While that is generally accurate, we have uncovered indications that occasional movement of material does take place on the moon. See if you can discern the evidence in this image as I pan across. The focus is on the rim of the expansive 32 kilometers wide Kepler crater. Notice along the crater wall, signs of landslides have occurred, evident in the dark material seemingly descending the slope. Let's delve into a closer inspection of the most prominent landslide within this crater. The source of the material appears to be box canyons located at the upper reaches of the crater rim. The descending material is notably fine, likely less than a meter in size, preventing the resolution of individual rocks within the slide. Interestingly, the larger rocks that became dislodged appear to have successfully reached the bottom of the crater floor. What adds intrigue is that the primary mass of the slide appears to consist of numerous smaller slide masses, indicating that the event may not have occurred all at once, but rather unfolded gradually over time. These slides are likely triggered by the impact of minuscule meteors striking the crater wall. The cumulative effect of these tiny impacts and subsequent landslides contributes to the smoothing of crater edges. This phenomenon is why the Moon's older craters appear smoother compared to the more recent ones. Here's another enigma for us to unravel. Behold, the intriguing Messier crater. While craters typically exhibit a round shape, Messier crater defies convention with its elongated form and a slit for a crater floor. What could be the explanation for this unique configuration? The plot thickens as we zoom out. In close proximity to Messier crater, two additional craters come into view. The one on the left appears significantly older, showing signs of weathering compared to the fresh impact crater on the right. Could the newer crater have coincidentally obscured an older one? Yet, as we zoom out once more, are there additional clues that can shed light on this mystery? A significant clue lies in the rays emanating from the crater, known as rays, which indicate the direction of debris dispersion following the impact. While rounded craters like Tycho exhibit debris scattering in all directions, Messier crater's rays tell a different story. Here, debris extends in three distinct directions: northward and southward from one crater and exclusively westward from another. What could explain this pattern? The answer lies in an impactor striking the surface at an exceptionally low angle, less than 15 degrees. Remarkably, in this case, it appears that the impactor had already fragmented into three parts before reaching the Moon's surface. All three craters likely experienced impacts almost simultaneously, including the seemingly older crater. The intriguing twist is that the ejecta from the second crater probably fell directly onto the other crater due to the low angle of impact, artificially aging it. This image unveils additional intriguing elements, such as the solidified impact melt pool at the crater's base and a region that seems to have experienced subsidence. The impact melt in the first image appears to have flowed towards the left, adding to the complexity of these captivating craters. In the subsequent image, the scenery appears relatively barren, with only a solitary peak bathed in sunlight. What makes this noteworthy? The peak is situated on the rim of Epinus crater, found near the Moon's North Pole. This location holds significance for future lunar colonies, as settlements are expected to be established near the North and South Poles. Deep within these craters, where sunlight seldom reaches, substantial reserves of water ice can be found, crucial resources for sustaining any lunar colony. Water holds immense importance for potential lunar colonies, serving essential purposes such as drinking, washing, cooking, and farming. Additionally, breaking down H2O into oxygen and hydrogen can provide breathable air and rocket fuel. The polar regions, where future colonies are anticipated, offer a unique advantage with peaks that are often exposed to sunlight. This is in contrast to other lunar areas with a 28-day day and night cycle, where extended periods of darkness pose challenges for solar-powered systems. While peaks like the one highlighted in the video may still experience darkness depending on the time of year, they remain an ideal location for solar panels, providing power to a colony for approximately 89% of the time, a significant improvement compared to other lunar regions with only 50% sunlight exposure. As a parting note, explore a couple more intriguing features on the far side of the Moon within Baba crater. These are the central peaks nestled in the heart of this expansive 80 kilometers wide complex crater. Thank you for watching. If you found the video enjoyable, I hope to earn your subscription today.